Light. We infer the position of objects in our environment by assuming that light moves from object to our eyes in straight-line paths. It is noticed that light rays from the sun entering a dust-filled room from a small opening. We see that light rays form parallel lines. Light coming out of small openings in between the trees seem to travel along straight lines. Rectilinear propagation of light. If a small wave-like nature of light is neglected, one finds that light propagates along a straight line. This straight line propagation of light is called rectilinear propagation of light. This is evident from many phenomena which occur in nature, namely formation of shadows and eclipses. Take a lit candle. View it through a pipe. First, when the pipe is straight, and second, when the pipe is bent. We will find that when the pipe is straight, we can easily see the lit candle, but not when the pipe is bent. This shows that light travels along a straight line. A number of different phenomena are connected with the rectilinear propagation of light. One such phenomenon is the formation of shadows. Transparent, translucent, and opaque materials. A substance through which light propagates or tends to propagate is called a medium. It is of the following three kinds: transparent. It is a medium through which light propagates easily or passes easily, for example, glass, water, etc. Translucent. It is a medium through which light propagates partially, example, tracing paper, grounded glass, etc. Opaque. It is a medium through which light cannot propagate, example, wood, iron, etc. Reflection of light. When a light ray traveling in a medium encounters a boundary leading into a second medium, part of the incident ray is thrown back into the original medium. This is termed as reflection of light. Reflection is of two types: specular reflection or regular reflection, diffuse reflection or irregular reflection. This shows several rays of a beam of light incident on a smooth mirror-like reflecting surface. The reflected rays are parallel to each other. Reflection of light from such a smooth surface is called specular reflection or regular reflection. On the other hand, if the reflecting surface is rough, the surface will reflect the rays in various directions. Reflection from any rough surface is known as diffuse reflection or irregular reflection. Water is a good reflector of light. We can easily see our image in water. In ancient times, there were no mirrors and people used to see their reflection in water. We cannot see objects in a room where there is no light because image of an object is formed only if it reflects light. Laws of reflection. The rays of light suffering reflection from reflecting surfaces obey the following two laws called the laws of reflection. The angle of incidence I is equal to the angle of reflection R. The incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. Consider a light ray traveling in air and incident at an angle on a flat, smooth surface. The incident ray, AO, and the reflected ray, BO, make angles I and R respectively with a line ON drawn perpendicular to the surface at the point of incidence O. This shows that angle I is equal to angle R. A plane mirror. A plane mirror is a plane reflecting surface. Any plane surface which can reflect light falling on it into the same medium is called a mirror. Any highly polished surface can act as a mirror. Example, plane mirror, steel mirror, water. Consider a point source of light placed at point O, distance u, in front of a plane mirror. The distance u is often referred to as the object distance. Light rays leave the source and are reflected from the mirror obeying the laws of reflection. After reflection, the rays diverge, spread out. These diverging rays appear to the viewer to come from a point I located behind the mirror. Point I is called the image of the object O. Images are formed at the point where rays of light actually intersect or at the point from where they appear to originate. Since the rays appear to originate at I, which is at a distance v behind the mirror, this is the location of the image. The distance v is often referred to as the image distance. Characteristics of image. The image seen in a plane mirror is always virtual for real objects because it cannot be obtained on a screen. Real images can be displayed on a screen, but virtual images cannot be displayed on a screen. If standing in front of a plane mirror, you close your left eye, your image in the plane mirror seems to be you are closing the right eye. If there is a mark on your right cheek, the mirror shows it on your left cheek. In a plane mirror, the left and right sides are interchanged. It appears that the image has been reversed sideways, that is, left becomes right and right becomes left. Thus, the image formed by a plane mirror suffers from lateral inversion. You will also find that the size of your image in the mirror is same as your own size. It means that a plane mirror produces an image of the same size as that of the object. Thus, a plane mirror produces an image which is virtual, erect and upright and of the same size. Real and virtual images. Images are classified as real or virtual. Real image. A real image is one in which light rays actually intersect or pass through the image point. A real image can be obtained on a screen. When we watch a movie in a cinema hall, the images formed on the screen are real images. These images are formed by a convex lens which is used in a movie projector. A real image is always inverted and is formed in front of the mirror. Virtual image. A virtual image is one in which the light rays do not pass through the image point but appear to diverge from that point. A virtual image cannot be obtained on a screen. Spherical mirrors. A mirror is a reflecting surface. We have already familiarized ourselves with the type of mirror called plane mirror. Another variety of mirrors are the curved mirrors. The curved mirrors converge, bring together, or diverge, spread out the rays of light incident on them. The most common type of curved mirrors is the spherical mirror. A spherical mirror is a part of a spherical reflecting surface. Spherical mirrors are of two types: concave mirror and convex mirror. Concave mirror. If the inside or the concave side of a spherical surface is polished such that reflection takes place at its surface, then it is called a concave mirror or a converging mirror. Convex mirror. If the outside or the convex surface is polished such that the reflection takes place at this surface, then it is called a convex mirror or a diverging mirror. Uses of spherical mirrors. Concave mirror. To collect heat radiations in solar devices. Heat radiation from the sun coming from infinity is brought to focus by the concave mirror in its focal plane or at the focus. Reflecting mirror for projecting lamps. The object is placed at the center of curvature to obtain an image of the same size. In floodlights, the source of light is placed just beyond the center of curvature. This illuminates a certain section of the ground. In torches, headlights, the source of light is placed at the focus to obtain a parallel beam of light. Shaving mirror, dentist mirror. It produces an erect virtual and highly magnified image of an object placed between its pole and focus. It is used in the ophthalmoscope by doctors to concentrate light on a small region which is to be examined. Convex mirror. It is used as a rear-view mirror in automobiles. This is due to the reason that a convex mirror provides a wider field of view than a plane or concave mirror. It produces an erect, diminished, and virtual image. It is used as a reflector in sheet lamps so as to diverge light over a large area. It is used as a security mirror in shops and on roads as sharp bends and concealed entrances. Both these mirrors can be combined to produce fun mirrors. A closer look at spectacles tells us that they are made of glass through which we can see. This is a special glass and is called a lens. Lenses. The most familiar and widely used optical device is the lens. A lens is an optical system with two refracting surfaces. The simplest lens has two spherical surfaces close enough together that we can neglect the distance between them. Such a lens is called a thin lens. The two common types of lenses are converging lens or convex lens, diverging lens or concave lens. Converging lens or convex lens. This lens is thicker in the middle and thinner at the edges. It can produce both virtual and real image. Diverging lens or concave lens. This lens is thinner in the middle and thicker at the edges. It can produce only virtual image. These lenses are used in various optical devices like camera, telescope, microscope, spectacles, etc. A convex lens increases the size of the image, whereas a concave lens decreases the size of the image. Colors of light. Have you seen a CD or a compact disc used in your computers and CD players? Take a CD out in the sun. When you see light reflected from its shining surface, we will see many colors. These colors actually come from the white light that we get from the sun. The white light of the sun consists of 7 colors. When we pass this light through a prism, it splits white light into its 7 constituent colors, abbreviated as Vibgyor. This was discovered by Sir Isaac Newton. To study the results of combining colors, Newton constructed a circular disc, divided it into 7 parts, and painted these with the 7 colors of the spectrum. When the disc is rotated rapidly, the disc looks white, or more correctly, grayish-white.